Hi, this is Mrs. Slater, and in today's lessons we will be discussing collinearity, betweenness, triangle inequality, and assumptions. Let's first start with the definition of collinear. It means that the points are on the same line. Like in this picture, A, B, and C would be collinear because they're on the same segment. Okay, non-collinear is the opposite. We're going to have points not on the same line or segment, and points like D, E, and F in this picture, we cannot get a line to form or to connect all three of those. And then the third definition I need you to know is definition of betweenness. It is a point that is between 2 points only if collinear. Okay, so in the two different cases we're going to discuss are right here. Case 1 is the one that works. So collinear means, for example, D, R, and E would be the collinear points. We could say that DR is a length of 7 and RE is a length of 3, and together they would make a total of 10. They're collinear, therefore you can make an equation because of definition of betweenness. So DR plus RE would equal DE. In case number 2, when it's non-collinear, you can see that it's not going to work. So you have, let's say, AMI. Here is your connection between the 3 points. AM is 8, MI is 6, and if you connect AI, you know it's not going to be a total of 14. It is going to be, let's say, 10. Just give it a random number, but we know it's not going to be 14. So in this case, when it's non-collinear, AM plus MI does not equal AI. So you cannot use definition of betweenness when it's non-collinear. To practice some of these definitions, the first question is, what are the angles with a vertex of M? Well, in this case, if you look to see where M is, you can see that there are 1, 2, 3 different angles that you can name with a vertex of M. So there are lots of different ways to describe that. First of all, we cannot use just M because there's too many angles around there. Second of all, we'd have to use 3 letters. So you have angle A, M, H. There's just one example, and you also could do HMA. The next one we could use is AMP or AMT if you'd like to use the T, or PMA. The next one is angle PMH, which is also angle 1. So if you see a number in there, you can use that just for a quick reference. Okay, now let's go on to collinear. If you look at H, points H and C, you can connect those two, and if it is a line, so it is going to extend in both directions. So we are going to have to include the points that are collinear would be M and N. Okay, and then as far as the definition of betweenness, let's take a look at that one. If you connect M and C, and then you're describing all the points that are between M and C, we could say that it's H and N, okay, because they are collinear. And naming the points of M and G, the two of them are non-collinear. Even if you did make one that is a line joining them, there is no points between them. So in this case, it is not possible. The last definition that you're going to need to know is the triangle inequality theorem, which says that the sum of any 2 sides of a triangle must be greater than the third side. So if you look at the first one, 5, 6, and 7, if you always just look at the smallest 2 and add them together to get 11, that will have to be, the third side would have to be greater than the other 2 sides. So as you can see here, since 11 is greater than 7, this indeed will make a triangle. Okay, check the next one. 1 and 2 are the smallest, and 1 plus 2, as you know, is 3. It is not greater than 3, so this one does not make a triangle. And go ahead and push pause and do the next two. So hopefully you have 2 and 5 is the ones chosen. 7 is not greater than 8, so this does not make a triangle. And the last one, the smallest, is 8. 8 is greater than 7, so it does make a triangle. The last part of this lesson is all about what to and how to interpret a diagram. There are things that you can assume from a picture, and there's things that you cannot assume. And you're going to have lots of pictures in your whole year of geometry. Anyway, what you can assume is that if a line looks straight, it is indeed straight. Same with an angle. If it looks like a straight angle, it is a straight angle. Okay? Also, collinearity of points. Okay, so for example, you have A, E, and C. They look collinear in the picture, so you can assume that they are collinear. Also, betweenness. Since E looks like it is between A and C, you can say that E is definitely between them. And then the last one, we can assume position of points. Okay, so right here, like point D, even though there's not like a big point there, we can assume that that is where they're connecting, is that position. Okay, what you cannot assume, and this is what's really going to trick you sometimes, so you got to be really careful. Right angles is a big one that you cannot assume. Okay, and then the right angle, this is given it's a right angle, so you can say, okay, that's a right angle. But right here, it looks like a right angle. But we don't know because they didn't tell us anything in the directions and it doesn't say. So we cannot assume that that is a right angle. You can also, you can't assume congruent segments unless there are tick marks, like in the previous 2 slides. You cannot assume that 2 angles are congruent unless it's given in the directions or you have some kind of marking on it. You cannot assume relative sizes of segments and angles. So what that means is if you have a segment like AB and then you have maybe a segment over here that looks a little longer, you cannot assume that CD is greater than AB. So cannot assume that one's bigger than the other or one angle is bigger than the other. Okay, well that's all I have for today, and that's all for now. Bye.